Hi everyone, welcome back. Today we are solving delete columns to make sorted 3. So this problem is very similar to delete columns to make sorted 2. The only difference is that in 2 will kind of be like a dictionary. We want to make sure all the words in the array are sorted lexicographically. But for delete columns to make sorted 3, we need to make sure that within each string, the letters of itself are all sorted lexicographically. And we want to return the minimum possible number of columns that we can delete. Or in other words, the minimum number of deletions of the same index characters in each string to make every single string in STRS sorted lexicographically. So if we look at this example, the minimum will be 3 because one way we will have to do it is remove index 0, 1, and 4. And afterwards, the array will be BC and AZ. BC is sorted, AZ is also sorted lexicographically. And for example 2, we will have to delete 4 of the characters, and each character on its own is obviously sorted lexicographically. So EDCPA is literally sorted reverse, so we will have to delete 4 of them to make them sorted. So that's why we return 4. And in the last example, GHI is sorted, DEF is sorted, and ABC is also sorted. So we don't need to remove any characters. They're already sorted, so that's why we return 0. So now that we have seen some examples, let's get to how we can solve this problem. So for this problem, I will be referring to each string as a row. So this will be a row and this will be a row. And I will refer to each specific index of each string as a column. So these two are in the same column and these two are in the same column. And how we can solve this is we can use dynamic programming. So we will basically just check between each two letters for all rows. And if all rows are in orders, then we will look at the dynamic programming array that we have. So for example, let's say we see that AZ and BC are both in lexicographical order. Then we will look here and we will look at where it matches. And we will take the max between the current here or 1 plus this. So that means we can add a new sequence here. So then we'll change that to 2. And in the end, we will return the length of one of the strings minus the maximum value in DP. So let's go over this example real quick. So we will look at them from the back all the way to the front. For the left character, we will start from second to last all the way to the front. For the right character, we will start from the letter right to the left of it and all the way to the end. So CA is not alphabetical, so we can move on. Yeah, ZB is not alphabetical, but doesn't matter. As long as we see this, we can move on. Now, BC is alphabetical. AZ is also alphabetical, so we look here. Initially, it was at 1, and we can change it to 2 because we can add 1 to 1. So that's why it's 2. Now we can move on to the next sequence. And from now on, I will just list both of them just to speed it up, but just know that when we code it out, we will have to look at them one by one. So this one is not lexicographical, so we just move on. This is not lexicographical, so look at the next one. These two are lexicographical, so we'll look at here, 1 plus 1 is 2, so that's why we change this to 2. This is lexicographical, so we can add 1 here to make it 2, or take what's already here, which it's already 2, so we don't have to change anything. Now, next one, BABB, not lexicographical, move on. Not lexicographical, move on. BC is lexicographical, BZ is also lexicographical, so we add 1 from here. So now it's 2. This is not lexicographical, so we can move on. And now that we have come to the end, we can return the length of the string minus the max in DP, which is 5 minus 2, which is 3. And as you can see, the maximum number of letters that we can have lexicographically is 2. So that's why we need to remove 3 of the letters. And the time complexity would be O of nm squared, where n is the number of rows and m is the number of columns, because we will obviously have to look through each row and we will have to look through the columns in a nested for loop, one for the green one and another loop for the blue one, and we have to check that all of them are in order, so that's why the n is here, the number of rows, and the space complexity would be O of m, because this DP array will depend on the number of columns. So now let's get to the coding part. So first we will set up the DP to 1 times the length of strings of 0, which is the number of columns. Now we will look through the columns. So for I in range, length of strings of 0 minus 2, minus 1, and we'll decrement by -1. And now for the other column, so it will be to the right of it, so I plus 1 to the all the way to the end, so length of strings of 0, so it will be I and j. And initially we will assume that it is in order, so we set order to true. Now we will look through each row, and if we see that if any of them are not in order, so if row I is greater than j, we will set order to false. And I will just break out the for loop to speed it up, even though when I did the example walkthrough I didn't do that. Now if it is ordered, then we can check the DP and update it. So we will update between the max of what's already at DP of that index to 1 plus the DP of j. And finally, after looping through, we can return the length of the number of columns minus the maximum value in DP. Okay, let's see if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.